Hi students, in this video we will continue to discuss the concepts of logarithms. Already we learnt definition of logarithm. Based on the definition of the logarithm, we can say that a power x is equal to n and log n to the base a is equal to x are equivalent relations. We can also write a power x is equal to n as anti-log of x to the base a is equal to n. So we just maintain the values in the left hand side as it is and the right hand value side is as it is. So we can write anti-log of x to the base a is equal to n. We will learn about anti-log in the last part of logarithms. Just you know this. Now we will discuss some example problems. Now we are expected to convert this exponent form into logarithmic form as well as in anti-logarithmic form. You know that in logarithmic form this 81 will come to this place and 3 will be maintained as base and this 4 will go to opposite side. And if you want to write it in the anti-log concept, everything will be maintained as it is. Left hand side values will be written in left hand side, right hand side value will be written in right hand side. So anti-log of 4 to the base 3 is equal to 81. I hope you understand this now. Now we will move on to the next question. Now we need to convert this exponential form into logarithmic form. The exponential form is 9 to the power of half is equal to 3. You know that log form can be written as log of 3 to the base 9 is equal to half. If you want to write this in anti-log form, anti-log of half to the base 9 is equal to 3. I hope you are clear with this concept. Now we are going to see some laws of logarithms. These laws play very important role in solving the problems. So you just listen to all these concepts carefully. The first rule is log of m into n to the base a can be written as log m to the base a plus log n to the base a. Here single logarithm presents, but in the answer we have two logarithms with different numbers. So whenever we have log and the numbers in multiplication means we can convert them into two logs and addition. So log of m into n to the base a can be written as log m to the base a plus log n to the base a. For example, if log 3 into 5 is to the base 2 means it can be written in two different log terms, that is log 3 to the base 2 plus log 5 to the base 2. Using this rule we have written it in two logarithmic terms. Now we will move on to the next rule. This is the division rule. The first one is product rule, second one is division rule. Log m divided by n to the base a can be written as log m to the base a minus log n to the base a. Now we will see an example related to this form. Log 5 by 3 to the base 2 can be written as log 5 to the base 2 minus log 3 to the base 2. Now we will see the third rule. Log m power n. This power n is only for m to the base a can be written as n into log m to the base a. This n, the power n will come to front. You just look at this. The power n has come to the front and the remaining things has been written as it is log m to the base a. We will look at the example. Log 3 to the power of 4 to the base 2 can be written as 4. This power 4 has come to the front. 4 into log 3 to the base 2. We will see one more example related to the same concept. Log root 15 to the base 3 can be written as log 15 to the power of half to the base 3. You know that if this number is in the power form, the power will come front. So 1 by 2 into log 15 to the base 3. Now we will move on to the next rule, that is log 1. to any base. Log 1 to the base a is equal to 0. You may ask how it comes. You just convert it into exponential form. You will come to know about it. When we convert this into exponential form, it becomes a power 0. We know that anything power 0 is 1. That's why log 1 to the base a is equal to 0. A can be any number, but log 1 means answer is 0. And then we will go to the next concept. Log a to the base a is equal to 1. Base and this number is same means answer is 1. You convert this into exponential form, you will come to know that a power 1 is equal to a. I hope you understand this. And these formulas are higher level formulas, that is base changing formulas. The sixth one is log m to the base a. Here base of this expression is a, but if you look at this, here base is changed. So log m to the base b into log b to the base a. Here base is b, here in this number we have b. Using this we are going to learn about base changing formula. We can change the base of the expression. If the expression is based on this expression, we can say log b to the base a can be written as log m to the base a divided by log m to the base b. This term comes to the opposite side. So we can say that log m to the base b. Here using this we are going to see the base changing formula. You observe this very carefully. Log m to the base b, here base is b, can be written as log m, this value log m to the base a divided by log b to the base a. Here log m base is a, log b value is also a, but here base value is b. This formula is called as base changing formula. This formula has been derived based on this formula. If log m to the base b has been kept as it is, means we can transfer this to the opposite side, so we get this formula. This is a base changing formula. Now we are going to derive one more formula based on this sixth formula. If we substitute m value as a in log m to the base a, here if we substitute in place of m, if we substitute a, we get log a to the base a. When base and this value is same, means we already learned which is equal to 1. Hence this expression value, when m value is equal to a, means it becomes 1. So this expression can be again written. Here in this formula we substituted m value as a, so log a to the base a is equal to log a to the base b into log b to the base a. In place of m we have substituted a in this expression. So based on it we can say that log a to the base b into log b to the base a is equal to 1, because when we substitute m value as a in this expression, we are getting this expression, and m value as a means this expression becomes this, and this value is equal to 1, from which we can say log b to the base a can be written as 1 divided by, this term can be brought down here, 1 divided by log a to the base b. If you look at these expressions, base and this value got interchanged. Whenever you want to change base and this value, when you want to interchange it, you can introduce that formula. Now we will see some example problems based on base changing. Here log 25 to the base 4 can be written as log 25 to the base 10 divided by log 4 to the base 10. Here it is not necessary that we should write 10, we can write any base, but normally we use 10, so we are writing it. We can use other base also, so you know that it is a base changing formula. Now you look at this. In this formula we want to interchange the base and this value. Log 10 to the base 7 can be written as 1 divided by log 7 to the base 10. We have interchanged base and this value. These formulae play very important role in higher level problems of logarithmic concepts. I hope you understand this concept. Please remember all these formulae. These are very important formulae. We will see the derivation of these formulae in the IIT classes. Thank you students, thanks for your cooperation.